Good day, everyone. Today is another day of learning. But before anything else, I would like to ask you, how are you? I hope everyone is doing good and may that feel stays with you until the end of the week. To start with, what can you see in this slide presentation? I think we are thinking the same thing. These are rock formation. Do you know how this phenomenon happened? Our lesson for today will let you know the answer. Our topic for today is about the earth materials and processes, focusing on exogenic processes. For today's lesson, you are expected to 1. Describe how rocks undergo weathering. 2. Explain how the products of weathering are carried away by the erosion and deposited elsewhere. And lastly, differentiate erosion to mass wasting. The Earth's geosphere is made up of different layers, and on Earth's continental crust, we can see different rock formation just like this one. The fascinating question is, what makes this natural phenomena? The different rock formations that are visible on the Earth's continental crust are possible because of the process called exogenic process. These processes are happening on Earth's surface due to the influence of exogenic forces. Weathering, erosion, deposition, and mass movement are the main exogenic processes. One of the exogenic processes that are happening in the Earth's geosphere is called weathering. This is the process where rock is broken down or dissolved into smaller pieces by physical, chemical, or biological weathering processes. Just like what can you see here in this slide presentation, these are all products of weathering. One of the main types of weathering is called physical weathering. It is happening because of the different physical factors such as freezing and thawing, temperature, rain, wind, waves, water pressure, and others that can cause rocks to break up into tiny pieces. Specific types of physical weathering occur in specific places. Physical weathering are happening because of different physical factors, just like what I have mentioned earlier. And one of these factors is called temperature changes. The sun's energy can heat up rocks to very high temperatures. This causes rocks like granite, an example of an igneous rock, to expand. As temperatures fall, the rocks cool down and contract. Continuous expansion and contraction causes pressure on the outer layers of the rock. Cracks develop as a result, and eventually, the outer layers of the rock wear off, and this process is called exfoliation. This illustration summarizes the process called freezing and thawing. And these are real examples of physical weathering. Physical weathering, please remember, it can happen from different places. Another physical factor that causes physical weathering are water and wind. Winds, water and waves found on rocks and wears them off. Prolonged action causes large rocks with rugged surfaces to smoothen. During runoff, water carries sand and smaller debris and smashes them against larger rocks in their path. The resulting abrasion causes wearing of rocks. These rock formations are examples of physical weathering caused by wind and water. If you are living near beaches, I think these rock formations are very familiar. Another reason why physical weathering is happening, that is because of the factor called freeze and thaw. Imagine this scenario. You are going to put a glass of water in a freezer, and after several hours, it will surely be freezing, and it will break up. What could be the reason for that? That is because water expands when it freezes. Just like here in the illustration, the rock has a lot of cracks, and water will enter in these cracks. It will surely be freezing and expanding the crack. And as the cracks deepen, there are more water entering and freezing on it. And when the process are happening repeatedly, it will break up the rock along the joint lines. And this process makes physical weathering. To give further elaboration on how freeze and thaw weathering is taking place, please pause this video and read this slide. These are real examples of freezing and thawing. Chemical weathering is another type of weathering. This is when weathering involves the reaction of some chemicals on the rocks. Take note of the word chemicals. Some rocks, such as limestone and chalk, are more prone to chemical weathering than others, such as granite. What could be the reason for that? This is because limestone contains minerals such as calcium carbonate, which readily reacts with rainwater. This chemical reaction produces new soluble substances that are easily washed away. This illustration shows an example of chemical weathering. Another type of weathering is called biological weathering. This process of weathering is very common, and we see it around us. A good example is an animal that can burrow into a crack in a rock. There are many insects, rodents, and bigger animals that live in holes in the ground or rocks. Constantly, they burrow and widen rocks and end up breaking rocks apart. Even algae growth is an example of biological weathering, because algae growth can weaken many rock types and make it more open to weathering. And you are no exception, because walking and construction activities that are made by humans, like road building, mining, and the like, involve people ripping rocks apart, and they all cause weathering. This illustration shows different examples of biological weathering, and I think all of us are very much familiar of this different scenario. We are now done discussing the different types of weathering. And to review all your learnings, please get your pen and paper, and let us all identify the different types of weathering that are being shown in each slide presentation. Let's have this as number 1. What about this? Number 2. And the last one. I think you got all the correct answer. Congratulations! Another type of exogenic process that are happening in the Earth's geosphere is called erosion. Erosion basically is a movement of rock pieces from one place to another. Once they have been loosened by the action of physical or chemical weathering. Erosion is not the same as weathering. Don't forget that. They are different. Erosion involves the movement of weathered rock, now pebbles, sand, or soil, from one place to another by the action of natural forces like wind, ice, water, and even gravity. There are two types of erosion. The first one is what we call the water erosion. Water erosion can occur anywhere that there is water in land or any rock surface. Water erosion can begin as soon as raindrops start falling. As more rain falls, the water runs over the land or rock surface, collecting weathered material with them. The power of moving water increases with more water, and its ability to carry heavy debris increases. Vegetation cover and mulch often help obstruct and reduce the impact of water erosion. Water erosion is more powerful on vertical slopes than on the gentle or flat ground. Let's examine this illustration. This illustration summarizes the process of water erosion. These are real pictures on how water erosion are happening. Another type of erosion is called wind erosion. Wind erosion is simply the removal of soil particles from the surface of the land and transporting them to another location. When the force of the wind is exerted on the land surface, the soil moves. The extent of movement depends on the amount of soil moved, the size of the soil particles, the cloudiness of the soil particles, and the velocity of the wind. Let's examine this illustration. This illustration basically shows how wind erosion is happening. Wind erosion starts with a process called dripping, where soil particles larger than 0.5 mm in diameter are dragged over the surface of the land because they are too heavy for the wind to lift up. As the particles roll and move along the surface, they bump into each other. The next process is called saltation. This is where particles involved are between 0.1 mm to 0.5 mm. The wind is able to lift them up briefly but drops them in a very short intervals. This results in a hop and bounce motion over the surface. Attrition is when the bouncing and jumping particles knock against each other and fly and break themselves up. And this one is the process called suspension, where particles like fine dirt and dust that are less than 0.1 mm in diameter. Wind is able to carry these particles over very long distances. It is probably the most common form of wind action and also the easiest to recognize. These illustrations basically shows all the processes that we mentioned earlier about wind erosion. If we already understood what are the different things that we need to know about erosion, let's try this true or false statement. Number 1. Water erosion happens anywhere where there is land surface but no presence of water. True or false? 2. Erosion affects agriculture. Is it true or false? Number 3. Particles like soil, dirt, dust, fragment of rocks ranging from 0.1 mm to 0.5 mm can be transported without wind. Is it true or false? And last item, erosion happens because of natural forces. Is it true or false? I think you got all the correct answer. Congratulations! This illustration basically shows how weathering is different from erosion. Weathering causes the rocks to break down, while erosion and transport moves the sediments downhill to another place. Another type of exogenic process is called mass movement. It is about movements of soil, sand, or rock debris down slopes, formerly termed as mass wasting. Mass movements on slopes and sinking mass movements are aided because of the time by gravity. One of the examples of mass movement is called landslide. It is a massive movement of rock, soil, debris, or earth material downwards along a hill or slope due to the force of gravity. The movement may be flowing, spreading, falling, toppling, sliding, and so on. This is an example of landslide that happens because of Typhoon Ompong that is considered to be the strongest tropical cyclone in 2018. It happens in the mining town in Cotogon, Benguet on September 15, 2018. Another example of mass movement is called mudslide. It is a fast-moving landslide, usually along a channel or canal, associated with the loose falling of debris. This is an example of mudslide that happens in February 2006 in southern native Philippines. There are around 1,229 fatalities. Landslides and mudslides are one of the most powerful and destructive natural and environmental events. They come almost when no one expects them, and they can occur and destroy things in a very short space of time. When they occur, they may cover a very small area, uphill to downhill, or may travel over several miles from their source. Depending on the volume and speed, it can wipe out anything in its path, such as houses, cars, trees, and electricity poles. And I think we are experiencing all these things here in the Philippines. People often use landslides and mudslides to mean one thing, but actually they are also known as landslips, slumps, or slope failure. There are many types of landslides such as blackslide, rockfall, art flow, creep, and so on. And to summarize all our learning for this lesson, let's try this activity again. Please pause this video and give yourself at least 5 minutes to accomplish this activity. So to summarize your learnings, explain this photo using everything that you have learned from this lesson. Make it concise and direct to the point. And for your peer activity on our next meeting, this activity is named Peer Discussion on the Role of Exogenic Process. Get a partner and discuss this question and make a summary of your discussion. And here is the question. How do exogenic processes perform their role in shaping the landform of an existing area? Make a list of your learnings about this matter, get a partner, and do a collaborative discussion. Submit a summary of your discussion. And of course, on our next meeting, I'll be calling you by pair and we will be hearing the summary of your discussion. Thank you for listening, and I think you have learned a lot of things today. And to end this meeting, I would like to remind everyone that your simplest act of kindness can spark a greater change. Once again, good afternoon everyone, and God bless.